for a given margin of error. I want to meet some allotted error. I want to be no more than, say, 3% away from the given proportion I'm trying to estimate. What sample size is necessary in order for me to achieve it? How many people do I have to ask so that I am no more than, say, 5% away from the actual? Polling, sampling can be very expensive. I have to pay people to take a sample. Campaign people, they'll pay some polling company to run a poll and get an estimate for support for a given candidate. Different manufacturing companies are interested in what of their products are defective. That's going to take time and money in order for us to investigate. So it's helpful to know how many different objects or people I have to sample so that I'm no more than some given proportion away from what I'm trying to estimate. What sampling level do I have to achieve so that I have a certain amount of accuracy in my sample? Or in my confidence interval, pardon me. All right, so from your formula sheet, what sample size is necessary for a given margin of error? I want the margin of error to be no more, less than or equal to, some previously given amount of error. I want to be no more than 3% away, no more than 5% away, no more than 6% away. I want the overall margin of error I'm going to calculate for my confidence interval to be less than or equal to some stated amount of error. The margin of error comes from this part of our formula, what I add or subtract. Our z-score times the square root of p times q over n. How many standard errors do I have to add on so that I capture a certain part of the normal distribution? That needs to be less than or equal to, let's just use E for error, some allotted error, previously identified error. Okay, we're trying to identify what sample size is necessary, which of these variables represent sample size. In this statement, which variable represents sample size? And we are going to solve this statement for n to put the sample size in terms of what else goes into making a confidence interval. So let's start solving for n. First up, get rid of multiplying by z on this left side. What's the opposite of multiplying by z? Divide. Divide both sides by z. Bring down the square root of pq over n, less than or equal to e over z. Error divided by the z-score. Okay, getting closer. Now let's take the square root away. What's the opposite of square rooting something? Squaring it. Square both sides. Square cancels out the square root. I'm left with p times q over n, less than or equal to the error divided by a z-score, quantity squared. Trying to solve for n. Right now, I'm dividing by n in that statement. So let's get rid of that part. Let's get rid of this fraction on the left. What can I multiply each side by? To get rid of dividing by n, what do I want to multiply by? N. I multiply each side by n. I cancel out the n from the left, leaving me p times q, less than or equal to n times e over z squared. Quantity e over z squared. All right, fraction got cleared away. We are one step away. Trying to solve for this n here on the right side. N is being multiplied by this part of our expression, e over z quantity squared. Let's multiply each side by the reciprocal of this ratio. Instead of e over z, the reciprocal is z over e. I'm multiplying these two together. Cancels out. And here is our expression for the sample size necessary for a given confidence interval. our sample size n is greater than or equal to, I'm going to read this backwards from right to left rather than left to right. Our sample size n is greater than or equal to p times q times quantity z over e squared. Grab your formula sheet. Could you flip over to the back? Go all the way to the bottom. There's a formula we just proved in class. The sample size necessary, where E is the maximum allotted error estimate. There are two different formulas. One is for means, one is for proportions. We'll come to this one later. You have this one here. Proportions now. The sample size necessary for proportions to make a specific confidence interval is P times Q times Z divided by our allotted error quantity squared. Just wanted to show you where that came from. Respect to margins of error. Let's put some of that into practice. Look at creating sample sizes a couple of different ways here. All right, we're going to do a couple things here with this first statement. Mr. Hansen is curious to know what proportion of photos on his phone are of his dog. After taking a random sample of 50 pictures on the phone, he finds that 18 of them are of his dog. Let's first create a 95% confidence interval to estimate the actual proportion of all the dog photos on my phone. A confidence interval is done by taking p hat plus or minus the margin of error. Z-score times the standard error of p hat, q hat over n. What is p hat? What is the sample proportion?
50.
That's the sample size. That's actually n.
18 over 50.
Second, Jeff?
18 over 50.
Of the sample of 50 pictures, 18 were of the dog, right? What's Q hat? What was the failures? What pictures were not of the dog in my sample? The other 32? Sample size was 50, we mentioned that. We're doing a 95% confidence interval, so what z-score do we need from your formula sheet? See mine? Go to your formula sheet, Maya. It's on the other one. For that z-score table on the front page. 95% CI will be what?
What?
Right, 95% confidence interval. Z-score is 1.96. We need to add and subtract 1.96 standard deviations, so we have captured 95% of the distribution. All right, let's plug and go. 18 out of 50 for p hat, our sample estimate, sample proportion, plus or minus the margin of error. 1.96 times standard error of the square root of 18 out of 50 times 32 out of 50 divided by sample size of 50. All right, let's get the margin of error built first. What do I have to take the plus or minus of? 1.96 times the square root of 18 divided by 50 times 32 divided by 50 over 50. 0.1330. This proportion here, what I'm going to underline, has a specific name. What is that called? margin of error. It's what you add or subtract away from p hat. It's the maximum difference between my estimate, the 18 pictures I found in my 50 picture sample, and the actual proportion of all the pictures on my phone that are of the dog. This is the margin of error. By adding and subtracting the margin of error, I can make the overall confidence interval. 18 out of 50. Let's get the left endpoint first. I'll subtract off the margin of error. So 0.2270. We'll add on the margin of error. Change the minus to a plus for the right endpoint of the interval. At 493. We are 95% certain that the actual proportion of all the photos on my phone that are of my dog are between 22.7% and 49.3%. Questions so far? Review on confidence interval. Okay. Question 2. Let's change the game a little bit. What sample size is necessary? How many pictures would I have to look at to cut the margin of error in half? I want to get a more accurate result. I want there to be less margin of error, half the margin of error. How many pictures would I have to look at? Would it be more or less than the original sample size of 50 pictures? Should it be more or less if I cut the margin of error in half? Why more, Jack?
Because if the sample size is bigger, that means that you're going to be more accurate. So
Margin of error goes down. As sample size goes up, margin of error goes down. If I take a look at more pictures, I have a more representative sample of the actual amount of photos on my phone. I want to get more accurate. I want to cut the margin of error in half. I want to know with more certainty what proportion of pictures on my phone are of the dog. Originally, the margin of error is 13.3%. I need to cut this in half. So let's take the original margin of error, divide it by 2. I want to be no more than 6.65% away. What sample size would produce this given margin of error? My error is going to be 0.066. I want to have a new margin of error, half of what I had previously, 6.65% versus 13.3%. What sample size makes that possible? Here's the formula in the back of your formula sheet that we proved a minute ago. Our sample size to produce a given margin of error is n greater than or equal to p, q, times quantity z over e squared. I already know my allotted error of 6.65%. What are p and q? What's an estimate for p and q? Say again, Nora? You've already said. I took a sample. Shouldn't it be pretty much the same over here? I have an estimate for p and q from what I did originally with my original confidence interval. P would be 18 of 50. Q would be 32 of 50. I still want to be 95% confident, so let's also use the original z-score of 1.96. Now I have everything I need to plug into the calculator. My sample size n is greater than or equal to at least or more 18 out of 50. 32 out of 50 for Q. Times quantity 1.96 divided by the new margin of error. Square. All right, so up on the screen. Paste that. I get 200.0000001. It's going to be hard for me to look at a fraction of a picture. I can only sample a whole numbered amount of objects. Do I want to round down to 200 or up to 201? Keeping in mind that I still need to be within the allotted margin of error. I want to round down to 200 pictures or up to 201, because I can't leave it like that. Can't sample a fraction of a picture. If I round down to 200, what does that do to the margin of error? Smaller sample sizes do what to the margin of error? So am I within the allotted margin of error if I round down? No. I need to always round up. Even if this is so close to 200, if I go down, I'm outside the error that I have to hit, right? Yeah. Even if this is so close. So if it's a whole number, if it was exactly 200, we'd have no problem. Leave it exactly 200, we're good to go. If it's anything else, you always have to go so that you hit the allotted error you're supposed to. Does that make sense? So 200 photos. Cut the margin of error. Roughly 4 times as many pictures to get half the margin of error. All right, let's do a couple more. End with this. We have our formula to estimate the sample size for a given margin of error. On questions 3 and 4, what sample size is necessary to be within 3% margin of error with 95% confidence? And in part 4, 99% confidence. I want to be within 3% margin of error, 95% assurance. I want to be no more than 3% away from my confidence interval with 95% certainty. What sample size is necessary? Say again, Chris? I'm sorry, not Chris.
Oh, no, we're using the same numbers as that.
It's a different question, I'm sorry.
Oh.
So 1 and 2 have nothing to do with 3 and 4. We have our formula. What's the z-score for a 95% confidence interval? That one you're going to know by heart by the end of the year. We're going to use that one a lot. What's the allotted error? Margin of error is what? 0.03. What are P and Q? I don't have the P and Q from the sample because I haven't taken a sample yet. Let's assume a worst case scenario. As much error as possible. Going back to my formula sheet, what values of P and Q make the margin of error as big as possible? I want to assume a worst case scenario, as much variability as there could potentially be. What do P and Q have to add up to? Keep that in mind. 1. So P and Q have to add to 1 and have the greatest possible product. What are P and Q both equal to? 0.5. There's a 50-50 split between haves and have-nots, successes and failures. That's going to produce as much error as possible. 0.5 times 0.5 is bigger than 0.6 times 0.4, or 0.7 times 0.3, or 0.8 times 0.2. When you're not given a P and Q, assume as much volatility as you can. 50-50 split, 0.5 and 0.4. Plug everything in. N greater than or equal to 0.5 times 0.5 times 196 divided by 3%, 1 squared. Before I type this into my calculator, I bet it's going to be a decimal. What's the rule for decimals? Even if it was this close to 200, like on the last one, you always still round. 1067.11. So what's our answer? 1060. It's going to be hard for me to pull a fraction of something, sample a fraction of something. So round to the whole number that's greater than that, 1060 inches. Be within 3% with 95% assurance requires a sample size of 1,068 objects, assuming an even 50-50 split. Do part 4. Please work on part 4. What sample size is necessary so that we're no more than 3% away with 99% certainty? What do you know about n already as you're typing this into your calculator? Would it be bigger or smaller than 1,068? Bigger. It has to be bigger. I'm more certain. To be more certain requires a larger sample size. What's the only number I'm going to change on the screen? What's the new z-score now?
2.575.
P and Q are both what? 50-50 split. Good. N greater than or equal to 0.5 times 0.5 times 2.575, or 99% confidence, divided by our 3% margin of error of 1 squared. How do you round? We'll always do this wrong. What's your answer? 1841 or 42? 42. Yes, sir. Like we said, it's bigger. To be more certain requires a larger sample size. Before you go, please, why don't you have a seat? Tomorrow, I will be gone. So come to class. I'll have a couple of videos for you guys to watch and some practice to work on. If I get onto Schoology, let me show you what you're working on tomorrow, just so we're all clear before you go. Here on this podium, if the sub does not give you these, you will need them. Okay? That's where your next T tables and chi tables are at. On standard 19, by the end of the day tomorrow, see, I've had you work down through the first 9. So 10, 14. We should be down through 18 by the end of the day tomorrow. Since I'm not here, I'll leave you with some lecture videos to watch and practice to work. And your target is to hit number 18 by class tomorrow. Sound good? Yep. Rock and roll. Have a good rest of your day, guys. We'll see you on Monday when I'm back in town, back in the school.
Have a good weekend.
You too? Yeah. Sure, I feel like I just give it to you now. Do you want to make sure that the sub has this for everyone too? Just kind of remember for tomorrow that, hey, the sub needs to pass these out for everyone.
I'm not gonna be here.
Oh, duh.
That's what I know.
I thought you said you just wanted one now rather than waiting till tomorrow.
I just think I
Yeah. There's also a PDF copy like with everything else on Schoology too, but
Are you gonna keep these?
it's yours. That's why I laminated it.